वो है लेकिन वो हमारे पैरेलल होगा। ये कितने बजे है? ये 4:30 to 6:30 ये हमारा पैरेलल है सारा लोग टाइम पूरा। हाँ जी। We need the new sheets. आजा आजा। Assalamu alaikum. We're gonna start. Iftikhar, do you wanna? हम इधर बैठते हैं आवाज में। आजा नहीं आगे आजा इधर अच्छे सीनियर लोग। ये बैठे हैं।
आजा मैंने कहा नीचे आवाम में भी तो कोई होना चाहिए।
बिल्कुल नीचे ही बैठ जाते हैं।
लेकिन यहाँ पे मैं देख रहा हूँ इधर बैठने का नुकसान पता है कि अब आंखों में लाइट पड़ रही है।
नहीं ज़्यादा नुकसान ये है कि आपको सारों में जवाब देना पड़ेगा।
तो जवाब देने के लिए प्रेजेंटेशन कुछ की होगी तो
इसलिए मैं कह रहा हूँ वहीं बैठ जाते बेहतर।
Yeah, I can wait. I will wait.
Iftikhar, so yeah, Shafin is going to be the last. Yeah, we're waiting for two people. They're coming.
Assalamu alaikum. We're just waiting for a couple of people and then we'll start inshallah.
इनको इंट्रोडक्शन कराने के बाद मैं कहता हाँ करीब
या आप क्वेश्चन पूछिए आपने क्वेश्चन पूछा
अदील भाई अस्सलाम वालेकुम दो लोग आ रहे हैं they're on their way ठीक है अदील भाई आगे आ जाइए
ये छोटे कमरे में
ये नहीं देख
Assalamu alaikum. We are waiting for one more person and inshallah we'll start shortly.
फ्रंट रोज को फिल कर बता भाई
Okay, we will get started. This session is IAAAE session, and we have from 4:30 to 6:30, and we have several speakers here with us today with really great topics. So with that, I would like to request Dr. Faheem to please recite a few verses of the Holy Quran. Dr. Sir.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إذا جاء نصر الله والفتح ورأيت الناس يدخلون في دين الله أفواجا فسبح بحمد ربك واستغفره إنه كان توابا.
Jazakallah, Dr. Sahib. Our very first presenter we had to do a little bit of shuffling of the order. But I would like to request Iftikhar Khan Sahab to come and talk about his AI topic and also introduce himself. Jazakallah.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Iftikhar Khan. Brief introduction. I have originally from Pakistan, Lahore. I went to Punjab University. I did degree in computer science, and I moved to USA about 30 years ago. Since then, I have been in software engineering and IT field. Last 4 years has been on AI and machine learning in Capital One. Very recently, I'm in the process of starting my own consulting company. So if you would like to connect with me, please just find my name on LinkedIn, and then we can stay in touch. So for this next 15 minutes or so, I'm sure you will keep me honest on time, 15 minutes or so, we'll just cover a couple of topics with respect to green. Oh, sorry, I think it's working. Yes, thank you. We'll just cover a couple of topics with respect to AI. All of us have used the ChatGPT. At the same time, this particular topic I will cover a couple of basic concepts so that if and when you hear those, you feel very comfortable knowing that what are those? Green one, yeah. And then I will cover the augmentation to the AI model, any of that you are using in your current workplace. The reason we picked that topic, because in our workplace, we have some proprietary data, which we cannot really expose to the public domain. So that is what we will cover today. And of course, after this session, feel free to have follow-up discussions with me or anybody who's part of your workplace. I just did my introduction, so we can go to the next slide. ChatGPT, all of us have used it. Just want to give a brief history from the computer science point of view. This particular field is called machine learning. And in machine learning, there is different algorithms to implement. And the most advanced one is called deep learning, in a way that it works like a neural network in our brain. That particular field was not very advanced because it needs tons of calculations. So two important things happened in last couple of years. One, the computing power with GPUs and CPUs has been improving year over year. That means the computer we have now can do more calculation. That's one. Then there is also architecture, how these systems are designed. In 2017, Google researchers published a paper, and that particular design is called transformer architecture. It's also called attention mechanism. That's where the parallelism was able to happen. So now just imagine millions of calculations need to happen, and now computer can do in that parallel. Now we got that power to write more advanced models. I will just clarify some of the terminology. ChatGPT, the company name is OpenAI. They have this interface for us, which is the ChatGPT. There is a machine learning model behind the scene that's work. That particular model is called GPT. So I will explain a little bit differences in next couple of slides. All of us know ChatGPT became popular within months. Since then, it have advanced, and many other companies are also investing tons or millions of dollars or trillions of dollars, both on the advancement of the model itself, meaning how the algorithm can be optimized, how much data we can provide, but also on the infrastructure. Just I'm sure we have heard the news, Meta, just one of the parent company of Facebook, they are going to invest $600 billion just on the infrastructure. Total is trillions. Why? Because with more data, the model is going to become more smarter. That means we need to do faster calculations. So for now, just take away that here the algorithm is being optimized, more infrastructure is getting faster, we can provide more data, and it can do more amazing things. With that, let's go to another term, which is called large language model. So LLM technology, from technology point of view, all these AI models, they are LLM, they are large language models. So when I said behind chat GPT, GPT is the model, that means it's an LLM. If you've been using another one, Gemini, that means there is a model as LLM. So just remember, large language model simply mean there was a huge amount of data that was given to the model so that it can train itself. And I will explain the training a little bit. For our context, we are just going to assume it's a text data only. But we know multimodal models in a way that they have become so advanced, they can do image processing, they can do many, many things. But just for simplicity, it's a data. So think of how neurons work in human brain. Practically, it's all about a messaging system. So neurons take a message, process, transmit to the next one. Based on that very complex, highly orchestrated logic, it knows where to go. Even any of movement I'm making with my hand, billions of messages happened for this movement. Just think of that with numbers. Computer, the processing of the computer understand numbers only. It does not understand any language, any English, any word. It understands the numbers only. So think of those numbers those calculation on that number happening behind the scene in several layers. So that's what make it neural network in this context. And I will show how the model is being trained. And I will just show a little bit about numbers. Let's go to the next one. So how model is trained? All the public data that's available in, let's say it's English, all the public data is available, that's being taken. And there is a lot of data processing, like clean it up. If anything is duplicate, if anything is like super bias, we can just remove that. Then start training the model. This is where the model is calculating the weight with respect to how it saw the words together. Very simple example. If it saw cat, the word cat, it also saw the word dog, and most of time it saw these words in the context of a pet. So it may put cat and dog and pet closer to each other mathematically. So then it goes to the fine-tuning. So this is called pre-training. Fine-tuning is that now the model have kind of weight, it kind of know the relationship or the semantics, but it doesn't know how to concatenate a full sentence. So with fine-tuning, we give it the kind of response also, so that it can understand the semantics and it start responding similarly. I will go to next slide, but just for now, I will show a couple of numbers, but just takeaway for now is that what's happening behind the scene, all the relationship semantics understanding is being converted to numbers, so computer can math and generate the next number. A couple of other terminology. One is called token. It's important for us to understand as a user. In the way that algorithm will work, it will take everything as a token. In the first example, it may be same as a word. I said hello, comma, word is 3 tokens, but it may not be. It may like divide a word into 2 tokens. So the reason what we need to remember is that if we have about 75 words in our sentence or a paragraph, just assume it's about 100 tokens. The reason we need to understand token, because when we use ChatGPT or any other model, there is a limit how much input we can send. So that's the only thing we need to remember. Next one, please do not try to understand, please do not try to read the number, but just think the concept. I just said the relationship. Let's say in case of cat, it's a pet, maybe it have an owner, then we know about the owner, maybe owner lives in Maryland. So many things we know, behind the scene, they all become a big array of numbers. So just think how computer know that memory is just the number. As soon as numbers are there, it can do math on that. So just remember the embedding, meaning the numerical translation of the relationships. Again, please do not worry about the whole diagram. I just wanted to show this one because I just said at the top, this story is about a woman. Actually, I said, oh, sorry, there is a color coding. I said this story is about A. That's where I left. So the way transformer architecture works based on neural network is doing that billions of calculation. All it's doing at the end is calculating this probability. So based on some randomness, it will just pick the next word, and then it will do it again. Okay. Now I'm going to switch topic. 5 minutes? 6 minutes? Okay, thank you. Just switch topic. Let me just recap, because now we are going to become a user. Just for a minute, not maybe a minute, for 5 minutes, we can like a technologist, just to appreciate how the calculations are working, how is it able to like predict the next token. It just convert all the knowledge into number. It have been trained, pre-trained. Based on that, it can do the prediction. As a user, all of us, when we send a message, like an input, and we want to get a response, that's called the prompt. Simple prompts are very easy. You can just write anything. Here, write a story about something, it will do it. But in our practical use cases, it's very important to understand these elements that goes into a prompt. So I will go in this, I have another session, 5:30. In that one, we will go on each and every part, and we will take an example. But for now, just remember that we need to do prompt engineering to get a best response. Now, we have done prompts, we have ran it, but I will just take the first use case for now. Remember, many of our data is proprietary. Any workplace, any company, any your own company, wherever you're working, you cannot share that data to public. If a RFP was sent, only that particular employer knows what was the sent in that RFP. Public doesn't know. So same way, the model doesn't know. So we want to augment that knowledge to the model. That's where it's called RAG, and I will go over that. I just put that question. So any model, you run any model, you ask these questions. What is the total amount that we quoted on RFP XYZ, right? Some of them. Remember, the way LLM work, they generate the next token. They may still give a response. They may say, I do not know. Model may say a number. Model may say anything, because there might be some RFP they know. That's not what we are asking. We are asking a particular RFP our company submitted. Model doesn't know. Similarly, if you look at the other question, I tried to make it more engineering type of question. Model will not know. This is where the augmented knowledge base comes. What we typically do, request response. What we need to do to solve our particular use cases in our workplace environment, we just need to implement something called knowledge base. That's what we need to remember. That's the second takeaway after terminology. So any proprietary information, data, images, PDF, you name it, you can work with your engineering team. They know how to create a knowledge base. As soon as that is done, the same query will go to that knowledge base first. After going to that knowledge base, it gets all those contexts. Now, if we think about the previous question, now it knows which RFP we are talking about. Now it knows what amount we sent there. Now it knows this information. It will use that information in the context, and it will give you the most appropriate answer. Very last one. This is just a little bit more technology. So when we are uploading that documents, what's happening? That's why I showed the embeddings. So even in that process, it will like make smaller chunks of the documents. It will do the embeddings, then it will store in a database. At the time when we send the response, it will do similarity search. Because if we are asking about RFP, it will go there. In the other one, we are asking about some standards, it will go there. Then it will send that as part of the context. With that, I can conclude now to say that anytime you have a specific use case where you need to use a proprietary information in any way or form, the most common solution is called RAG, Retrieval Augmented Generation. With that, thank you very much. And I think I can answer my part of the question now.
Jazakallah. I think now we can ask the audience if they have any questions. I know we have some AI experts here too. So Atasaf, you can go. Please form a line and make sure the mic is turned on. And I would request the same on the Lajna side. If they have any questions, please make a line behind the mic.
Is it on? Okay, it looks like it's on. Assalamu alaikum. So I just wanted to know, you mentioned neural networks. So some platforms, like they have multiple communication networks, Loanworks, Modbus, and BackNet. So how does AI have them all communicate with each other? Because they're all on different platforms. And also you mentioned proprietary data. So how would your AI algorithm know that this is proprietary data? Well, this one is not, obviously, because when it's trying to make determination, you know, my guess is it will probably not go to that proprietary data. And thank you.
Thank you very much. I will answer the second one first. Model doesn't know it's proprietary, right? All it knows there is a knowledge base. Let me go there first. That's how it's architecture, right? If there is nothing in knowledge base, it will go to its own weight and biases, which was being calculated at the part of training. The first one, no, I have not heard those platform right way, so the same way, sorry. I will give maybe similar answer to a similar question. So when I said in 2017, Google researcher published a paper, it's called Transformer Architecture Using Self-Attention. If the question is about the design, that's what all the LLMs using. That means all the previous one were slow, they are not being used. If it's about something else, then we can discuss offline.
Jazakallah. Any questions on the Lajna side?
Assalamu alaikum.
Ji.
I had a question about the slide where you were talking about that this is A, and then it gave the suggestion of a woman. On the side there was like percentages, and I'm assuming that those are the likelihood that it would give that option. And I'm wondering, where does it get those percentages from? Like, where is it getting the suggestion to give woman rather than like man or child or something like that?
I heard half of the question. So,
Ji, can you repeat the question?
Yeah. So the question is actually about the slide where you talked about how it predicts the next word, that this is a woman one.
oh, okay, yes.
On the side, it gave like percentages, and I'm assuming that that was about how likely it is to suggest that word. And I'm wondering where it is getting that information. Like, why would it like suggest woman versus some of the other topics for this specific example? Like, why, or like, where is it getting the like those percentages of like recommending like man being 24 versus a couple being 2.5?
Yeah, I love that question. Just give me opportunity to explain this slide a little bit more. Very good question. So color coding is not showing up, but what I type was this story is about I just left there. Now look at all the far side, whatever right or left. You see, very first one is saying man. Story is about a man. Then I think it's showing stories about a young. Then it's showing stories about a woman and so many others. See, there is a probability. I think 24%, 18%, 12%. That's what model calculated. So far, so good. At the very top is saying temperature, top P, top K. Let's just discuss temperature for now. Temperature is a parameter that we as an engineer or user, we can set. Temperature is saying how much randomness you need to do. So in this case, it did the random, it just picked number 3. Every time it may pick a different one. Every time, right? If the temperature is high, if the temperature is lower, it may always pick the first one. In like bigger picture, it knows all the context because there might be something before this, before the story. We may say, hey, we are talking about Ahmed. And then we say this story is about, it may say Ahmed, it may say man. So based on the probability came from the model, based on temperature and top P, it just randomly select from those particular options. In this case, by chance it selected woman. If you try the same thing again, it may select man or young or something else. I hope that answers the question.
Yes, it does. Jazakallah.
Jazakallah. I think there's a question on the men's side.
Assalamu alaikum. So my question is more about the hardware that's working the language models or the AI is using. So like I'm a non-technical person, just want to understand that we talk about data centers, that we need a lot of data centers, we need a lot of processing power. So I'm sitting on my laptop and I send in a query that's processed somewhere in a data center, and then it comes back to me on my laptop. So how important is that laptop which is sitting in front of me, the processor which is in that laptop versus what's happening in the data center? So how do these different hardwares interface with each other?
Jazakallah, very good question. So where I just showed this slide again, just remember, billions of calculations are happening. Billions, right? That's what's driving the next token or the next world. In your example, Lisa, if the model is hosted somewhere else, laptop is just a browser. It's just my client. So I need like minimal power. I have installed models on my local as well, just to experiment. In that case, it needs the memory that model needs. So that's part one and part two. The bigger picture is that all these companies, as I mentioned, they are investing in infrastructure. Why? Because they want to be faster than others. Just the way ChatGPT works, it's like literally very fast. But it's going to become complex, then it will become more fast. Simple answer is that we as a user just need browser, we can use it. If we are in a company or a workplace, then we work with our technology department because they want to host model themselves. They do not want to use model outside of the company because then data is going out. In that case, they will work with, let's say, some cloud provider to get a secure account and deploy it there.
And any question on the lady side? Okay. In the interest of time, let's Jazakallah, this is great. So Iftikhar is going to be here for a few more.
5:30 session in room number 1101. I'm advertising that. I'm co-presenting with one of our members from the Lajna side. If you want to know more, we will take a use case, like a specific case study, and then we will just run our prompts on that to make it a reasoning process instead of just a question answer. So if you would like to, please attend. Jazakallah for the opportunity, and thank you to organizer, and special thanks to our
undergrad from Pakistan, UET, master PhD from George Washington University. I spent time with 15 years working for FAA. Then I was a test lead for Air Force. Some war equipment called joint threat emitter, different kind of missile system, how they test it. Then I served as senior engineer for F-35 program, the latest jet, which is used in this nasty word, I will say. So I was senior engineer for F-35 jets. Last 6 years, I'm serving for space, NASA. I'm holding office in NASA for Landsat mission, and I'm serving as a Landsat mission operations center manager. So that's my brief introduction. Okay. So I've been asked to speak something around space sciences and the Holy Quran, that is there something Holy Quran predicted about the space sciences and how we're doing, what we're doing at this point, exploring the space. Are there some kind of predictions or something which Holy Quran already mentioned 1,500 years ago? So I will say that Holy Quran actually set the basis for us that how we should explore the space. The verse of the Holy Quran you are seeing, أعوذ بالله من الشيطان الرجيم بسم الله يا معشر الجن والإنس إن استطعتم أن تنفذوا من أقطار السماوات والأرض فانفذوا لا تنفذون إلا بسلطان. That, oh mankind, if you want to cross the boundaries of planets and stars, you cannot do that. The only exception is you should have a logic and wisdom through which you will explore. So Allah has given us that wisdom, and regardlessly who is doing what, we are exploring this. If we are Muslim, we should be the first to jump on that, but other people who are they are doing the same path. They explore through research and dig into things and then build the models and do things, practically explore the whole space. So I will further explain, I will say, send my control, the next slide. How the humanity start from camel rides to then moving in motor vehicles, then the airplane, and now space. So we are exploring step by step. And we are going very fast. So I focus on I will little bit focus on the space things and will present a case especially for Landsat mission, what we're doing in the Landsat mission, and what it is to give like a kind of introduction of space and for the young audience that if they are interested in those kind of areas, what are the next steps for them to take? So when we're talking about space, around Earth, the first level is airspace. Airspace is the area where airplanes and air traffic is moving, and FAA is basically controlling that airspace and all those planes and etc., the humans, transportation in this airspace. Then the next level is where the satellites are moving. That's a space, outer space, maybe 100 kilometers above that. Our mission, which is Landsat mission, it is low orbit mission, and we are cruising our satellite around 700 kilometers. And then the deep space. Deep space means that beyond that, you go beyond that, explore the planets, Mars, and everything. So we are moving fast, exploring the space step by step. What we do, before I come to the Landsat system, what we try to explore through space, one thing is we are exploring that is there a life exists somewhere else in this universe or galaxy or whatever. And what we do, we went to Mars and we went to Moon and we're trying to do, exploring different planets and stars where the life. What's the first thing we do? We try to find if there's a presence of water. If the water is present, then we can think of that life will exist there. And amazingly, think about the Holy Quran predicted 14, 15 years ago that وَجَعَلْنَا مِنَ الْمَاءِ كُلَّ شَيْءٍ حَيٍّ أَفَلَا يُؤْمِنُونَ. That everywhere, when the life exists through water. And if there is a water, then there is a life, No, exactly the same thing we're doing. We first try to explore, there is a water, if there is no water, then, and it is such a kind of, it's everywhere. I mean, it's like think about your human body. It's filled with more than anything than water. Water is maybe 80+% in the body. Human is dying, the only thing, give him water, maybe save life. I will give one incident if I have time at the end, but I will stop here. I have to go on the Landsat mission, what I'm working on. So Landsat mission, we started in 1972, the first Landsat satellite. And we are cruising about, as I said, 700 kilometers. What we're doing, we are circling around the Earth. We are taking the images, the infrared kind of radiation we use to take the images and send to the ground, analyze the image, predict what's happening, what will happen to the Earth, what can happen, what are the challenges, how different things are affecting, and we do a lot of research. So that's what we are doing through one piece, that's what we're trying to do. So if you think about the satellite, there are major three components on the satellite system. The first segment is space segment, really the satellite itself, which is circling ground. Then is a ground segment. Ground segment include what I call mission operation center, or some people may understand as a control room or whatever control system, command and control. And then the launch system, where we launch the satellite and put in the orbit. That's basically are the basic component of standard kind of satellite system we are putting on the orbit. Somehow it's not visible, but these are like, I don't know, some writing is gone, but I don't know why. So this is basically the main component is Mission Operations Center, which is controlling the satellites and commanding the satellite to do certain things, what we want to do, what kind of the images, what area of the land we have to take the images, and what angle and all of details. A lot of things happening when your satellite is cruising. We have to maintain the orbits. We have to do a lot of things. Maybe in the next slide I will go a little more detail. But here it is showing the top box in the blue is Mission Operation Center. Then the lower box likely is showing data acquisition and processing system, the images we collect, what to do, and kind of analysis, those kind of things. So these are different components. On the top, you're seeing the satellite and how we communicate to the Mission Operation Center, and then there are ground station. Ground station are really the area through which we communicate with the satellite. Okay. I've been warned that I have 2 minutes to go, so I will be quick. So this is like a basic structure for, so this is like a major component what Mission Operations Center has, what we have like telemetry commands, we have trending analysis, how to do flight dynamics, how to control the flight. There are different challenges. Every day we have to develop mission, that what mission has to do with mission planning and scheduling, all those things. So if you are interested, you can Google it or something, maybe that one. What we do when the satellite is on, we launch after that. We put in the orbit, and then slowly we do the commissioning. Commissioning means that the different, now it is in the orbit, the different components start testing itself, self-diagnostic, and start operating, start communication with the ground, and the data start collecting, and when have what kind of data requests come and start, collecting and transmitting to the ground. So those kind of the daily kind of things we do in a mission operation center. So one thing, last thing I say that one thing, the satellite in the orbit, regularly we have to do one thing. Caravan. We have to maintain the orbit. If we don't maintain the orbit, we will be in trouble. So we constantly have to fix the orbit. And think about, and I quoted that Holy Quran exactly say that look at the stars and the planets. Kullun fi falakin yasbahun. Every, it is sun or moon and other planets, they have to be in specific path. The orbit, they are maintaining the orbits. If you don't do it, you'll be in trouble. So there's a guidance is already there. So we explore and we say, okay, the only way we can have a successful mission is that if we maintain the orbit. And exactly that's what the Quran guidance was, that we have to maintain that. And I think, what else? So, yeah, we can do, what else we can do with the satellites? Lot of things we can do. I will not go into detail. We can pretty much control anything and everything on this planet Earth from the satellite. It is providing every kind of means that we want to focus and we want to do things, that kind of thing. Yes, everything pretty much we can control through the satellite. Unfortunately, there are negative and there are positive. We can use for the war purposes and other things, those are negative, but there are some benefits, like anything happening on the earth, you can dig out what are the benefits or what are the dangers that we should be prepared for that. And what else? Well, this is what daily we do, everything, every day, what kind of things we are doing in Mission Operations Center. We are driving like a jet, I mean, in the airspace, but we are doing in the space. Every day we have a mission to complete. Every day we collect images. Every day we analyze things. We predict things, what's going to happen tomorrow. There are different things like in a daily business that what our satellites are doing. So more you can explore. That finally for the youngs, that who works for the space mission. I will say that anyone who has scientist, engineer, physicist, whoever has science background, their software developer, computer system engineers, all those people, they have some role in there. And if you feel that the area you want to explore, so all those fields are applicable, depend upon that what is your interest. I mean, if you are a theoretical person, maybe like a scientist kind of work. If you are engineers, maybe you do the simulation, you develop software, you do certain things. I think the last thing I have to say that challenge. I will skip it because I think I'm getting out of time. So, final thing I will say, Mission Operations Center. Sometimes we have challenges there, anomaly. Sometimes even the mission we are running, it may hit with the space debris or maybe even the other space traffic. So we have to do maneuvering. We do all kind of things, and we need unique scientists to explore and analyze and then give the answers. So we have to keep the smart people in the Mission Operations Center to do our things. What's our challenge? I mean, smart people, more expensive. We don't want to spend money on that. We want to save money. That's a big challenge. So where are we going? We are going to build a Mission Operations Center as much as possible human-free, as much we can. So we want to eliminate the humans, honestly, who do the key role, but we cannot afford them. We want to develop something which is less humans, but the machine do things. And here comes some kind of AI and machine learning and certain things, anomaly detection, prediction models, and all those things. The tools we build and we use to, do things human-free. So with that, I think, thank you very much. I appreciate your time. And unless if someone has a question, I'm here for you.
Jazakallah. And so what we can do is, maybe you're still here, so we can, if there are any questions, we can leave at the very end. But Jazakallah. It was very interesting topic, and we really hope to learn more from you and also inspire some of our youth, in this vast field of Landsat and satellite communication. So our next speaker is Hamid Hassan Saab, and I'll just do a quick introduction for him. Hamid Hassan Saab is a construction professional with over 18 years of experience in project controls and scheduling. He currently works as a scheduling manager in Virginia and has contributed to major infrastructure projects in Canada and the United States. He's passionate about planning, project controls, and helping others understand the value of effective scheduling in complex construction projects. And Hamid Sahib is a civil engineer by education. Him and I went to the same university back in Lahore, Pakistan, and so did Dr. Faheem as well. So with that, I want to let Hamid bhai speak.
Jazakallah, Ahmed. Just wait for the presentation. Let me learn this meanwhile. They'll load the presentation. Can you load the presentation on the importance of scheduling in the construction industry? Assalamu alaikum, everyone. My name is Ahmed Hassan. Jazakallah for the introduction as well. I'm a civil engineer. Been in the heavy civil construction industry for the last 18 years, and currently leading the scheduling team at Flatiron Integratus. So let's do a quick show of hands, and let me ask you a question. How many of you here have ever planned or scheduled something in Microsoft Project, Excel, or any tool? And keep your hands raised if you think the things did not go as well as you expected. So, well, that's scheduling in a nutshell. We plan for something, reality intervenes, and then we adjust. So, for this discussion today, consider scheduling as a roadmap of your project. So this roadmap is going to tell you what work needs to be done, how you're going to do it, and how different activities are going to depend on each other. Let's dive into it. So I'm saying time is money. Everyone knows about that. So on big jobs, construction jobs, even a single day of delay can cost a lot of money. So I'll give you an example. In a job of $500 million infrastructure project, if your job is delayed for just one day, your indirect expenses, including your crew, equipment, resources, overheads, it can go easily up to $50,000 per day. So you're a contractor, you have not budgeted for that, and you started to lose money just by losing one day. Now, on top of that, let's go to damages. So damages, on the other hand, it's a mechanism in the contract for the contractor to pay fines for staying longer on the job. So now we want to punish you because you are longer on the job. You were supposed to finish long ago, and you're not leaving. So $50,000 per day for additional costs because my excavators are there, my equipment is there, I'm losing money. And now the owner also wants to punish me and add liquidated damages. So what is that? So liquidated damages is basically a way of the owner calculating the loss of revenue. So if you're a hydroelectric plant operator and the hydro plant is not ready for operations, then you'll not be able to sell the electricity to the people, and obviously you will lose revenue. So the owner wants that money back through penalizing the contractor. So since this involves big dollars, and that's why, of course, everyone will fight about it, and there's a lot of litigation and arbitration in our construction industry just because of that, delays, damages. So the claims are there. Now, these delays are fundamentally driven by time. So the time calculation is actually done by the forensic scheduling. And that's why forensic scheduling is something very critical these days in our industry. This is a specialty where you just not plan things, but really look into the plans and trying to figure out who caused those delays and who's responsible for it. Because if you are not responsible for it as a contractor, then you will not be penalized for this. And the owner has to take care of all those delays, costs for you, and the damages as well. Now, so what is the schedule? So most people think that schedule is about calendars and dates. Now, schedule is actually about, in simple terms, trying to model reality before the reality happens. So Outlook is not a schedule. So we use a CPM schedule in which the CPM basically has the ability to show dependencies and constraints and the sequencing and basically risks and how to recover those risks. So when I said constraints and risks, so let me explain what do I mean by constraints. So from constraints, I mean that you're working on a rail track project and you're 25 feet close to a rail, and as a contractor, when the rail comes in, I'm not supposed to be 25 feet close to a moving rail. So I will be told to go back and to maintain that 25 feet. And then when the train crosses, then I'll be told to come back. And every time a train comes in and goes by, I have a lot of disruptions and I lose productivity. So that is a constraint in a train track project we face. Similarly, when you're working with utilities and the utilities are not removed prior to the foundation work, so that is another constraint on your job. Resources, availability could be another constraint. Risks are unforeseen problems that can possibly happen on the job, and it can cause delays on the job. So there are multiple examples of risks. We will just go through some of them. But the idea, what I want to tell you is that in this CPM model, basically we can play with those constraints and risks. And when you change one thing, it is going to tell you a different outcome. And it will tell you how the finish date is going to look like and what is going to be the impacts on your job. So basically, it gives us an ability to foresee how the things are going to happen. So that's a simple example of what scheduling is. So now, this picture, this photograph I'm showing to show the importance of the coordination and the interface requirements in the construction project. So you can see in this picture, you can see a lot of utilities. There are some inspectors standing on the left side of the photograph. There's a lot of equipment, materials. You see the weather constraint on the top of the clouds. It's about to rain. We're working very close to the river, and any little bit of flooding is going to create a chaos in the site. So there's a lot of operations here, and this photograph just alone shows you how important it is that somebody manages those constraints and that interface requirements properly. Otherwise, we will be turning this project into a disaster. So just now, so we are talking about the importance of scheduling. So again, when we lose time, it affects cost. We talked about it in slide 1 because you are going to be on the job for additional number of days, and you're going to have the equipment additional costs, the crew is additional costs, resources additional costs, and now you are losing money. So the contractor naturally is trying to recover. So the costs are going to affect the resources because now I'm going to add more resources into the job, try to recover those additional days. But guess what? When I add additional resources, additional equipment, and additional crews into the site, I hit that economies of scale because you can't have a lot of people working in the same area, and you are going to lose productivity in this case. So the reason for showing this ripple effect is the scheduler does not have to really tell you that what is the delay happening today, but in fact, the scheduler needs to tell you that what is going to be the end outcome because of the initial delays on the job, right? So we need to analyze those ripple effects. The scheduler helps the team see problems. So the challenge in this statement here is that we always, or most of the time, come to know about the problems when they are already become impacts. But the job of the scheduler and the team is to really see those risks and see and identify those bottlenecks in the project and keep an eye on the changing conditions. So I've been told there's 2 minutes left, so I'll just move to some of the important parts. So schedulers connect disciplines. So as you know, like designer looks at the design, procurement looks into the procurement, construction crews are just focusing on the next day. But the thing is that these all departments always try to work alone in silos. There has to be somebody that needs to bring them in on one page. So in fact, in reality, design is going to affect the procurement, and procurement is going to affect the construction, and construction is going to affect the commissioning, and of course, the final project handover. So the integrated master schedule gives everybody in the team the ability to be on the same page and have the common language. So I'll just talk about the plan B in this slide. So we have to be ready if there are problems happen. So I'll just give you an example. I was working on a project not long ago where we had some utilities in the area where we had to do the foundation work. And the owner was very confident that they will be able to finish the job in time. But our team was skeptical. And we started exploring other options that what is the actual work we will be able to do while the owner is relocating those utilities. So we started working on some other areas, and we were able to run some work in parallel. Although the utilities were relocated after 10 months, but the whole schedule only showed the impact of 5 months. So we recovered a lot of time. The schedule brings visibility on the table. So it tells you what is happening on the schedule or on the project today. And it's also going to give you a forecast of what is really going to happen in a week from now or 2 weeks from now. So I'll give you an example for that. So let's say if you have to do 30,000 cubic yards of earthwork in a month, and you are, after 5 days into the job, you're only doing 800, 900 cubic yards. So now you can do a predictive analysis and really say that you're not going to finish in 30 days. And you can change the model and really show the impacts on the job in this case. So last slide. So what happens in construction, when the time increases, it affects everything. So it affects your indirect costs. Crew is going to be longer. Supervision is going to be longer. Project management costs are going to be higher. It has more risk exposure of different kinds. It has chances to, the prices of materials, equipment, and labor is going to go up. And now you're going to even lose more money. So similarly is with the disruption. So the goal of the scheduling is that how we protect both time and money. And what we tried to do today is to really see that how it helps with coordination, interface management, brings more visibility on the table, and gives, turn the uncertain situation into a more real, foreseeable future, so you can plan accordingly. So that is the end of my presentation. Thank you so much for listening.
Jazakallah, Hamid Saab. Because we want to leave a little time at the end for the Faheem Saab's questions. Since this is a very diverse topic or range of topics, I just want to ask if somebody here has any questions about scheduling from Hamid Saab. Go ahead, please.
Assalamu alaikum. So looking at your slide up here, if you do the planning, the network scheduling, planning, and you plan activities on the critical path, does that help you with managing it? And if you implement AI, do you think that will help you as well?
Listen, yeah. So when we schedule something, so obviously the critical path activities are the ones we need to really focus on. The critical activities which are not on the critical path, we do not focus on them. So obviously they have to be done at some point, but the critical path is the path which is going to drive your end date. So 100%, like we focus always on the critical path because that determines the final completion on the job. So I think I answered your first part of the question, right? So on the AI part, so we have been exploring a tool called Alice for the last 6 months. I'm getting trainings for that like every couple of hours, every week for a few hours. So at the moment, my feedback on that to my team was that it's not there yet because it depends on who is developing it, who is giving or teaching that model, but it's changing every week, every month. So I think there's going to be AI tools for scheduling very soon, maybe much earlier than what I expect.
Jazakallah. Any questions from Lajna side? Jazakallah, Hamid Saab. Again, Hamid Saab is here even a little bit later after this, so if anybody has any questions about, specifically about construction scheduling, mashallah, he's an expert in that. So with that, let's move on to the next speaker here. And our next talk is Hadia, from Hadia Malik Sahiba. Hadia Malik Sahiba is a recent graduate. And you know, mashallah, she's been really helping us with a lot of our Jamaat projects. And her topic is about designing equity, how architecture can reduce global disparities. So with that, Hadia Sahiba, please, the floor is yours.
Assalamu alaikum. Jazakallah for the introduction. Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. So when we discuss disparities, our minds often go to healthcare, education, or policy, but one of the most influential factors is our built environment. And so that consists of buildings, streets, and public spaces. And as architects, our design choices have a direct impact on equity and inclusion. And so today I'll explore how universal design can help reduce these disparities by creating spaces that work for the widest range of people. So let's take a minute to look at these stairs leading to the US Capitol and think about the type of people who would have a hard time climbing these steps. And of course, the first thought is going to be wheelchair users, but what about the elderly, pregnant women, someone recovering from surgery? And so God forbid, any one of us could come across a situation where climbing these stairs would become a challenge. And unfortunately, this has been a reality for many Americans throughout our history. So, so this image is from the 1990 Capitol Crawl, a pivotal protest in the disability rights civil movement, when activists abandoned their mobility devices to crawl up the steps of the US Capitol in an effort to fight the daily exclusion and discrimination they faced. The Capitol Crawl helped bring national attention to these inequities and became a major catalyst for the passage of the Americans with Disabilities Act. Now, hopefully we've all heard of the Americans with Disability Act, ADA, and it was a game changer for the physical accessibility for all these individuals. And over the last 3 years after its passage in 1990, these regulations have expanded into education, employment, healthcare, transforming the lives of millions of people. But as our understanding of inclusion is evolving, we have to look beyond just compliance. So the ADA standard regulations focus on physical metrics, things like making sure a door is 36 inches wide, but they often miss the actual user experience. So true inclusion asks us, is the space easy to navigate? Does it consider neurodivergence, sensory needs, or the language barriers? And can everyone experience a space the same way an able-bodied person does? And this is where we begin to see the difference between compliance and inclusion. ADA focuses on legal requirements, but universal design philosophy focuses on the human experience. The difference is someone can physically reach the space versus does that person feel welcomed, valued, and are they able to participate in the building and in the experience? And so with that, let's talk about what universal design is. And in simple terms, universal design refers to the design of an environment so that it can be accessed, understood, and used to the greatest extent possible by all people, regardless of size, ability, disability. And just as a stat, according to the World Health Organization, over 1.6 billion people, about 16% of the global population, live with some type of disability. And so as designers, as professionals, it's essential that we think about this population when it comes to our work. And so prioritizing human diversity, universal design guidelines consist of 7 principles that architects and designers should incorporate from their initial phase of design conception. And I'll only be going over 3, but if you want to learn more, feel free to scan this QR code to follow along. And so the first principle is equitable use. And what that means is that the design works for everyone without separating, stigmatizing, or singling anyone out. And to put this into perspective, imagine you're arriving at a building with your friends. Everyone is able-bodied and you got injured and you're in a wheelchair now. Everyone has the ability to walk up these beautiful stairs, grand entrance, but you as a wheelchair user have to take the side entrance, walk a long way, and then have to see the dumpsters. It's just not a pleasant environment, right? Technically, according to ADA standards, the accessibility is there, but your experience wasn't equal. And so the solution, implementing the universal design guidelines, would be that the entire plaza gradually slopes up to the building, making the accessible route the primary route, right? Principle 2 is flexibility in use. So people have different abilities, preferences, and the way they interact in a space. And good design provides options rather than forcing everyone to one way of doing things. So let's think about a library, how there's multiple areas. There's collaborative tables, there's quiet study rooms. And so universal design provides both, rather than assuming that there's only one solution and that only works with everyone else. There are choices. And with that, the third principle that I'm covering is simple and intuitive use. That spaces should be easy to understand for everyone. A bad example would be entering a building and you're having to solely rely on complicated signs, confusing corridors, and where you would constantly need directions just to find the basic destinations. But the solution would be that the building itself becomes the guide. And so universal design requires architects to think about the full range of the human experience from the very beginning of the design process. And so what does universal design actually look like in practice? What's a good building? So this is the Ed Roberts campus in Berkeley, California, and it features accessibility as the footprint, as the whole concept itself. The building consists of many universal design features consisting of a sloping spiral ramp, easy wayfinding, natural lighting, accessible gathering spaces, multiple ways of circulation, sensory and cognitive abilities to be able to use the building independently, and much more. It also addresses the disparities, as can be seen in this diagram. It offers direct access to train station and sophisticated air filtration system. It also offers acoustic zones, flooring textures, and the other things to create a truly inclusive building for all the different types of users, whether someone's blind, someone can't hear, someone is using a wheelchair. So this building perfectly demonstrates the core idea of universal design, that when we design for those who may face the greatest barriers, we often create environments that are more usable and convenient for all. And this, I will transition into this effect called the curb cut effect, and I love this explanation. So curb cuts were originally designed to help wheelchair users navigate sidewalks independently, but after their inception, curb cuts were then used by everyone: parents pushing strollers, travelers rolling their luggage, delivery workers, even young children. And this is known as the curb cut effect, that when we design for people who face barriers, we often end up creating solutions that benefit everyone. And with that, we can take our lesson from the curb cut effect and find a connection to the Holy Quran. And do not forget to do good to one another, chapter 2, verse 238. And putting that verse into the architectural perspective, doing good means thinking beyond the average user and considering those who are often overlooked. So the architectural promise is simple: not just creating spaces people can enter, but creating spaces where everyone can participate, contribute, and belong. Jazakallah.
Jazakallah for, and this is an amazing presentation. Hopefully we can build all of our masajid and the future buildings that we work with and make them very equitable for everybody. We have a few minutes for quick questions. Any questions from the men's side about the presentation? Okay. Can you bring it up, the presentation back up, please, if you don't mind? Please, go ahead. Go ahead.
I'm Dr. Ran. I'm a family physician, and so when I hear talks about disability, it's actually quite interesting to me. But I also know that in the world of healthcare, we are unfortunately very financially motivated, and as I get older, I see this in various aspects of other fields as well. I'm sure architecture and construction included. My question is, are there, to put it very bluntly, financial motives for building more accessible spaces like the ones you've been mentioning?
I definitely think there are, because, again, I think I'm not an expert in any way. I just did a disability studies minor in contracts to my bachelor's in architecture. But obviously there is, the financial aspect of creating accessible spaces. And there is, honestly, I don't think there's enough incentive in the construction world. And I haven't been able to find a lot of firms that actively want to implement universal design. And I think that part of what I would want to do in my future is to figure out these resources and to see if there's a way we can, implement universal design. Because I think I was listening to the neurodiversity talk upstairs, and it was really interesting. And I was wondering, if professionals can, use architecture instead of having medical intervention, instead of having physical intervention instead of the medical intervention to rectify some issues that people with autism might face, right? The sensory overload, right? Instead of having medication, just building better lighting systems, having better acoustics. So I don't know if I've answered your question, but I think that there isn't enough, and we should, as professionals in all fields, create that incentive.
Exactly, you answered my question.
Jazakallah. Just to add a little bit onto that, I know back in the day, a few decades ago, there was a big drive to have more energy efficient buildings and more energy efficient construction projects. So on the building side, they did the LEED certification, which actually forces a building, as somebody's designing it, to make it more environmentally sustainable. On the large infrastructure project, we have an Envision certification, which is somewhat similar, but I really hope down the road we develop a certification to make construction projects equitable, accessible, right from that perspective. So, or it becomes part of the LEED, which helps the environment, and it becomes a requirement for at least public facilities that are used, including hospitals, stations and all that kind of stuff. So, inshallah. Any questions from a Lajna side on this
Yes,
topic? Please, go ahead.
Just come here. Oh, the mic's not working.
Assalamu alaikum. Jazakallah for that presentation. My question was, thinking about our masjids and any new construction projects in the Jamaat, what are some tangible ways in which we kind of think about universal design when we're thinking about prayer spaces and masjids? Jazakallah.
Jazakallah for that question. So in terms of I have the opportunity to help with the National Lajna Conference Center, and we are in the initial design phases. And I think that ways to incorporate things, we see stairs all around. Like even to enter this building, there were a couple of stairs, and there were ramps, right? But like the example I mentioned in my presentation, instead of just having stairs, create a naturally sloping entrance that takes away the need of having a ramp. And I think that what I need to do more research on is like how, like a prayer hall, it's really it's stimulating, especially on things like Eid, right, the dining hall. How do people with autism, how do people with ADHD survive those spaces, or how can they have a good experience? So I think that there probably is research. I'm just starting my education and hoping that I can come back with better answers. But yeah, there's aspects, there's this design guide called Aspects for people with autism. And one of the projects that I was working on for my school, I use those, and they offer, they give you guidelines, things like having planning, can't remember exactly, but if you look up Aspects design guide, there's a lot of design guides out there, a lot of research is being done. And I'm hoping that I can eventually be a part of that research too and bring something back to you guys.
Jazakallah. All right, so we're in the next half hour, and our next and last speaker for today is Shafin Munir Sahab. Shafin Sahab's introduction that he has provided me is, Shafin Munir Sahab is a virtual design and construction engineer at DPR Construction, and a recent graduate of the University of Maryland School of Architecture. With a strong foundation in design, construction technology, and project coordination, he's passionate about leveraging innovative building solutions to improve project efficiency and collaboration across multidisciplinary teams. During his academic career, he earned Dean's List recognition, reflecting his commitment to excellence and professional growth. He's also pursuing a master's degree in building information modeling and further advance his expertise. Shafin Sahib also is, mashallah, helping out with several IAAAE projects, and he is also contributed as a video editor at MTA USA. In addition, he also helps with this Senate Tijarat Department, the local Jamaat leadership, and he has a lot of, he's combined his experience in construction, architecture, media, and community service. He is building a lot of strong relationships in this regard. So with that, I would like to request Shafin Sahib to come here and tell us about this fascinating world of virtual design and construction. Jazakallah.
Assalamu alaikum warahmatullahi wabarakatuh. Jazakallah. Junaid Saab, for the warm introduction. So, what is virtual design construction? So, this is a new emerging field which is being sort of delivered in the architecture, engineering, and even in trades and in obviously construction. So, virtual design construction is not a singular application or a software. It's the use of technologies to basically build the entire project virtually first, which allows everyone involved, from the architects to engineers to the owner itself and the subcontractors, to basically see how the building will perform and how long it will take to be built, and effectively of like how much it will cost. So it's going to entirely basically save a lot of money in the long process of first having it made on a virtual environment first. So the parts of VDC include BIM, which is building information modeling that's with 3D models, and it's linked to data. And then there's integrated concurrent engineering, which is real-time cross-discipline collaboration, metrics and KPIs, and the last thing is digital workflows, which is cloud-based design, where everybody can kind of collaborate on and execute their roles effectively. So BIM is essentially the backbone of VDC, from all the way from 3D geometry to 8D. So three-dimensional is basically from clash-free, the modeling application, to scheduling, to cost, to sustainability, effectiveness, to facility management, to finally the safety of the codes of the project itself. Next, we'll take a look at the different the implementations of VDC across the architecture, engineering, construction fields. So in architecture, it's used a lot for authoring Revit, AutoCAD, real-time design validation, design exploration, coordinating a floor plan drawings to productive form of the model, and client of visualization and VR walkthroughs. For an engineer, it's very emphasized in MEP, mechanical, electrical, and plumbing. They also do a lot of automated clash detection across the software application. to basically see where there's a wall and a pipe intersecting, and for the a simulation to phasing and sequences. And for trades, prefabrication data and the model, it can be also understood by implementing this VDC application. It's the same thing for field engineering as well. RFI reductions, because if it's a virtual model, everybody can see the updated system and clouds, and as-built model documentation. So in reality, the business case for VDC is there's 38% of reduction in RFI and change orders. There's 20% decrease in the construction cost, 7% in the schedule savings overall, and 3 times the ROI and VDC implementation. Now, the common implementation issues with VDC is the high upfront cost of the software, hardware, and the individual who is knowledgeable in this. The lack of a contractual framework for model ownership, because since everybody can have access to it, you don't know who was the original owner, so that's a good and a bad at the same time. And because it's a new field emerging, there's a skilled VDC talent shortage out there. And these are basically the common tools used among these 4 different fields, essentially. But the main one is Autodesk Revit and Naviswork. These 2 are basically the backbone of virtual design construction. So where is VDC going? So in the future, there's going to be a lot of AI implemented into it, AR and VR in the field, digital twins, which is essentially there's 2 different point clouds of that project. One could be on your iPad in the field, and then the main one is like essentially like in your main office. Integrated project deliveries more increased, and mass fabrication is also, and then common data environments, because as the world goes more towards AI and higher technology advancement, this VDC field will just become more reliable in that sense of utilizing those applications. So VDC isn't a trend. These are the 5 key takeaways. VDC is not BIM. Like, those are 2 different things. BIM is a cloud of all the applications that architects, engineers use. VDC is the process of utilizing, essentially, utilizing BIM. So the question isn't no longer like if we should adopt it, it's how fast a a construction firm should adopt it because it will solve a lot of issues before a project is like hit the ground. Jazakallah. That's it.
Jazakallah Shafin Sahab for this amazing presentation about virtual design and construction. We still have a few minutes. So any questions from the men's side, please come to the mic. Jazakallah.
Assalamu alaikum, Jazakallah Shafin Sahab. Very interesting presentation. Just wanted to ask a question. So with VDCs in the job, the 100%, it reduces, it improves the efficiency on the job and with the clash detection and all. So what I have come to notice that oftentimes the contractor is not we are doing it in some jobs, but like most of the time, those jobs are sponsored by owner. They want a BIM model, and then since we have a BIM model, so let's do 4D scheduling in that as well. But whenever we bring that up in general for new projects, like our teams are not interested to do it because of the costs associated with that. But it 100%, I agree, it later on definitely reduces the cost. So how do you see this problem getting resolved? Because that's something I'm also very interested in that and would like to move more into the 4D scheduling side of it. But always I see the cost becomes a challenge because the VDC teams, they want some cost deducted from our project because they charge a lot of money to build those models for us and do that work.
So right now it's more of the higher prestigious firm that can afford the VDC teams and stuff, but inshallah I plan to open up my own consultation firm with VDC equipment and stuff, so let's see where Lamia, I guess, he takes me.
Jazakallah. And again, Shafin Sahab is going to be here for any follow-ups. Any questions from Lajna about VDC? Okay, Shafin Sahab, Jazakallah. I think I agree with the folks that are associated with construction. I mean, this is the future, and of course with AI, I mean, this is kind of like a perfect storm, right? That I know that I deal with a lot of projects with very high costs and very tough schedules. And cost is driving everything these days. So I think hopefully some of these tools in the future can help us, do the jobs faster, maybe with machines and no humans. I think somebody was mentioning that less humans and more machines, and we do more with less, right? I think that's the goal here. So Jazakallah for that. Again, any questions that anybody has, please. I also, right now, for the next few minutes, or like 5 minutes, I want to give an opportunity for anybody to ask questions to Dr. Faheem. I know that his presentation went a little over, but I just want to ask if anybody has any questions about Landsat, satellites, the amazing world that's beyond this Earth. So this is the opportunity to ask that question. So please come to the mic if anybody has any questions. We'll start with men side, please. Okay, we have one question.
No question is a good question.
Just quickly, please, because I'd also like to take a moment to introduce a few people here.
Assalamu alaikum. So, how do you determine that your satellite remains in the correct orbit?
How we determine the satellite is what?
How the satellite rotates on the correct orbit.
How do you make sure the satellite stays in the correct orbit?
So that I said that we continuously monitor. If I use the terms state health, we are collecting, there are a lot of sensors in the landers and spacecraft, and we are collecting the information. We are measuring the orbits. When it loses the orbit at certain limitation it crosses, we do the calibration, we change its route. That is a continuous process. Almost every 2 weeks, we fix the orbit so that it don't go somewhere else. we do certain things under certain kind of situations. You talk about the orbit, is a little related thing I will explain. Like space debris, meteors, other satellite, make light, and we do maneuvering. We exactly do like in a war zone, the jets do the maneuvering to save from the missile attacks and everything. Pretty much same thing we do in space. If something is going to collide with that, we change the orbit, we bring it back, all those kind of maneuvering techniques we use. So simple, quick answer to your question, yes, we continuously monitor and we change the orbit, not change the orbit, correct the orbit so that it remain in the fixed orbit. Is that answer?
Jazakallah, Dr. Saab.
Thank you.
Anji, Assalamualaikum. So how is the AI being implemented, like in this,
How
our
is
space
the AI being implemented? Are you trying to say that how we can make, how we can benefit from the AI?
I guess both, yeah.
Yeah, that's the kind of challenge thing that exactly we are looking for. Different things we want to solve, where, as I said, that we put talented people to do things. But look, think about, they have like a standard options that, okay, if this is the case, then we'll do this. If this is the case, then we will do this. Like the example, the question he asked, like if it is deorbit or something, what we got to do? Certain kind of maneuvering. So yes, the future we are looking for is pretty much, instead of doing the one thing is automation. Certain things we are looking for AI to do smart thing in future prediction for anomaly to happen and the challenge we can come across. So those kind of the areas where the AI can help us. So those we're digging into, and we are conducting certain studies, and different vendors bring the proposal that, okay, this is the right way to do. Any other questions?
Jazakallah. Any question from Lajna for Dr. Faheem? Okay, Jazakallah. So we're going to cut the live stream now. Oh, I'm sorry. Assalamu alaikum. So we're going to cut the live stream.